My name is Ed Boyden. I'm an associate professor here at the MIT Media Lab and McGovern Institute in the departments of Brain and Cog Sci and Biological Engineering here at MIT. For hundreds of years, microscopists have been trying to look at biology. Typically, you take a glass lens and magnify the light coming from a sample, and you get an image that's bigger, and so you can see it. But there's a problem. All of these existing microscopy methods are limited. They can't take a three-dimensional image of a large sample with nanoscale precision. And so we thought, well, what if we did something different than the last 300 years? Rather than using glass lenses to magnify the rays of light, let's just blow up the actual sample and make it bigger.
So the way that this idea came about is that we actually spent several months just brainstorming about it in a very daydreamy kind of way. Oh, wouldn't it be great if we could just expand the tissue? You could see so much more detail by doing that, and wouldn't it be awesome?
We kind of threw out a lot of ideas and rejected a lot of ideas until finally something stuck. We discovered that by embedding a piece of tissue in a swellable material, you can physically expand that tissue.
So we looked through the literature and we just found the most well-characterized swellable polymer there is, which turns out to be the thing that is used in baby diapers.
So when baby diapers absorb water, there's polymers in here that will swell up to become very, very large. That's how they absorb so much water.
Expansion microscopy is not a new microscope. It's a series of steps which we apply to the sample to physically magnify it.
First, you label the structure you want to see with a fluorescent dye that will be anchored into the network. Second, you deliver the precursor and then you form the chemical network right there inside the specimen. Next, you have to chop up all the endogenous structure in the tissue so that it will not resist expansion. And then finally, you put it into pure salt-free water and it spontaneously expands. With this technology, the polymer network extends 4 to 5 times in all 3 dimensions evenly. So the relative shape of the structures you want to look at stays the same, it's just bigger.
This is important because this means anyone out in the world can apply those steps to their sample and put it on the microscopes that they already own to make their microscopes into super resolution microscopes. With expansion microscopy, we can image whole 3D volumes at a resolution of tens of nanometers.
What's cool about this is that you actually can start to try to navigate brain circuits. You can scan large chunks of brain tissue, but with nanoscale precision. And so we think that this technology can help a lot of different questions be answered in biology and in medicine.